In this lesson, we're going to learn about linear inequalities and their graphs. Here we see an example of a linear inequality. This is an inequality because we have an inequality symbol. In this case, a greater than symbol. Inequalities have solutions. Solutions are values that make the inequality true. If we have a list of points and we want to determine which are solutions, we simply need to substitute the values in for x and y and evaluate. If the inequality is true, we have a point that is a solution to the inequality. An inequality may have many solutions. In fact, inequalities will have infinitely many. Here we see two different points that are solutions to the inequality, and there are many more. We can also have values that are not solutions. Consider these points. When we substitute those into the inequality is false. In those cases, the points are not solutions to the inequality. Every inequality has a graph. In this lesson, we'll learn how to construct these graphs momentarily. But for now, look at this graph which represents this inequality. Each of the points that are in the solution set, such as -4, 3, are in the shaded region. Any point that is a solution can be found by looking at the graph and looking for the region that is shaded. All of those points in the shaded region are solutions, and all solutions will be in the shaded region. Points that are not solutions will be outside of the shaded region. Consider the point 2, -3. That's not in the shaded region of the graph, and therefore is not a solution. Consider the point 0, 3. 0, 3 is directly on the line. This line, however, is a dashed line. Therefore, this point is not a solution. Points that are on a solid line are considered solutions. They will make the inequality true. But points that are on a dashed line are not solutions. They will make the inequality false. Now let's look at how to graph an inequality, because the graphs are so valuable and because we'll want to use them frequently. Here are the steps that you'll follow. First, write the inequality in slope-intercept form. Next, graph the line. Your inequality symbol will tell you whether the line should be dashed or solid. If the symbol is simply a greater than or a less than, the line is dashed. If the symbol is greater than or equal to, or less than or equal to, the line will be solid. Finally, shade the solution set. Look at the inequality symbol. If your symbol is greater than or equal to, you will shade up from the line. If your symbol is less than or equal to, you will shade down from the line. Let's use these steps to construct a couple of graphs. In our first exercise, we want to graph the inequality y is less than or equal to 1/2 x plus 3. The first step is to write the inequality in slope-intercept form. That's already done, so we're ready to move on to step 2. Step 2 is to graph the line. We have the line y equals 1/2 x plus 3. The y-intercept is at 3, and the slope is 1/2, which allows us to plot additional points. Now we have to determine whether the line will be solid or dashed. We look at the inequality symbol. We have less than or equal to. Whenever we have an equal to in our symbol, we have a solid line. And so we draw a solid line through the points. Next, we need to shade the solution set. We need to determine whether we shade up or down from the line. Again, we'll use the inequality symbol to guide us. Our symbol is less than. Less than means to shade down. So we draw a little arrow down from the line, and that's direction in which we shade. Now we've completely drawn the graph of our inequality. Remember what this shaded region represents. Any point in the shaded region will make the inequality true. Any point outside of the shaded region will make the inequality false. What about the points on the line? Well, in this case, we have a solid line. Points on a solid line will make the inequality true. We'll get things like 2 is less than or equal to 2, or 5 is less than or equal to 5. Those are all true statements. The graph shows us the solution set and the values that will make the inequality true. Let's take a look at a second example. Here we have an inequality, negative 2x minus 3y is less than 18. We want to graph the inequality. The first step is to write the inequality in slope-intercept form. In other words, we get y alone on the left-hand side. We begin by writing down the inequality, and then we will follow the process for solving for y. Remember, when we divide by negative 3, we have to be careful. When we divide by a negative number, we have to change the direction of the inequality symbol. Written in slope-intercept form, y is greater than negative 2/3 x minus 3. We're now ready to move to step 2 and construct the graph. We start with the y-intercept. The y-intercept is at negative 3, and the slope is negative 2/3. We use the slope to plot additional points. Then we need to decide whether the line will be solid or dashed. Again, we look at the inequality symbol to determine whether this will be a solid line or a dashed line. We have simply a greater than symbol, which means we will have a dashed line. We construct the dashed line through the points on the graph. Finally, we're ready for step 3, shade the solution set. We have to determine whether we shade up or down. Again, we look at the inequality symbol. We have a greater than. Greater than makes me think up, so I'm going to shade up. I go to my line and I draw a little arrow upward. That's the area where my graph will be shaded. Once again, remember what the shaded area represents. Any point in the shaded region will make the inequality true. Any point in the unshaded region will make the inequality false. What about the points on the line? This time, we have a dashed line. Points on a dashed line are not solutions to the inequality. If we were to substitute points from the dashed line into the inequality, we would get statements like 3 is greater than 3, or 5 is greater than 5. Clearly not true. Now you know everything you need to know in order to get started graphing linear inequalities. Remember, you can learn more about inequalities in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.